Okay, as promised, we now will consider the topic of the R and S system of nomenclature for enantiomers. Okay, so recall from our lessons on nomenclature that every unique compound must have a unique name. So if enantiomers really are isomers, if they really are unique compounds, they must have different names. So by convention, we label each stereocenter as R or S according to the following rules. Okay, so the first rule is we're going to assign each group on a stereocenter a priority based on atomic number. Okay, so the highest atomic number gets priority 1, and the lowest atomic number, which is usually a hydrogen, is going to get priority 4. Okay, so let's look at a concrete example. We have a stereocenter at the center of this molecule, and the stereocenter, this carbon, contains an ethoxy group, which I'm just representing with a red ball in my model. It has a chlorine, which is the green ball, and it has a hydrogen, which is going to be the white ball. Okay, so we assign priorities to each of these. Chlorine has the highest atomic number, so it gets priority 1. I guess I'll hold it this way so this is pointing away from you. The oxygen is next highest atomic number, so it gets priority 2. Then comes the carbon, it gets priority 3. And finally, the hydrogen has the lowest atomic number, so it gets priority 4. Okay, secondly now, you want to orient the molecule so that the group of priority 4 is pointing away from you. Again, these are not rules that I made up. They're technically called the Kahn-Ingold-Prelog rules, after the 3 men who developed them. So yes, they made some arbitrary decisions, but as long as we agree on those arbitrary decisions, we'll all be fine and we'll be able to talk to each other and have the same meanings for R and S. Okay, so we're going to point the molecule so that the group of priority 4 is pointing away from you. So now, the remaining 3 groups that are all pointing a little bit towards you, if that hydrogen is pointing away from you, will trace out either a clockwise or counterclockwise circle as you go from priority 1 to priority 2 to priority 3. Okay, so in this case, the chlorine's priority 1, the oxygen is priority 2, the carbon is priority 3. So as we go from 1 to 2 to 3, we are tracing out a counterclockwise circle. So if you trace out a counterclockwise circle, then we say that this stereocenter has the S configuration. Okay, so as drawn, this molecule has the S configuration. If instead you traced out a clockwise circle going from priority 1 to priority 2 to priority 3, your stereocenter then has the R configuration. Okay, S comes from the Latin sinister, which means to the left, and as we trace out these circles in an S, your trace is moving to the left when you're on top of the circle. R comes from the Latin rectus, meaning the right. If it's the R configuration, you're moving towards the right at the top of the circle. Okay, so now you know how to do R and S for simple molecules, and this is something that is going to require a lot of practice. Do it with models, do it without models, figure out what works best for you. I think models are really, really important when doing these problems, at least in the beginning, until you start to get familiar enough that you can see some of these. Some people can never see two-dimensional objects on a piece of paper very clearly in 3 dimensions, and for them the models will always be useful. Okay, now this is a relatively simple case because the stereocenter had a chlorine, an oxygen, a carbon, and a hydrogen around it. What happens if 2 groups on the stereocenter have the same atomic number, usually carbon? Well, then what you need to do is keep going down each chain until you find a point of difference and break the tie at those atoms. 2-butanol is a fairly easy example to do. I'm actually going to do an example that's a little more difficult to illustrate this concept. Okay, so that's an alcohol similar to 2-butanol, but on one side we have a hexyl chain, just 6 carbons, and then on the other side we have an isobutyl group. Okay, remember your isobutyl groups from the lesson on nomenclature? So it is fairly obvious that the oxygen is going to get priority 1 and the hydrogen is going to get priority 4. But which of these carbon chains is going to get priority 2 and which one's going to get priority 3? Well, what we're going to do is look at the carbons highlighted in green and look at what is bound to each of these carbons. Okay, so the carbon on the left is bound to 2 hydrogens and another carbon, and the carbon on the right is bound to 2 hydrogens and another carbon. So far, they are completely identical. Therefore, we're going to continue down each chain to the next carbon. This is what we mean by keep going down each chain until you find a point of difference. Going 2 carbons out from the stereocenter, we now do find a point of difference. On the left side, that carbon is bound to 2 carbons and 1 hydrogen. On the right side, on the hexyl group, that second carbon from the stereocenter is bound to 1 other carbon and 2 hydrogens. Since carbon has a higher atomic number than hydrogen is, we will assign the isobutyl group to have priority 2 and the hexyl group to have priority 3. Note that even though the hexyl group is larger overall, having 6 carbons than the isobutyl group is, the rules, as we put them into practice, still have us assigning priority 2 to the isobutyl group. Okay, so some more tips, tricks, and pitfalls, as I like to say, relating to this topic. So if we look at a structure of 2-butanol, and if the molecule is drawn with dashes to the hydrogen, you can assign priorities to the other 3 groups and evaluate RS directly without doing any reorientation. Why is that? Because dashes mean that that atom is pointing away from you, so this hydrogen is already pointing away from you. So for the structure drawn on the screen, the OH is pointing towards you. Then we have the ethyl group, that's priority 2. The methyl group is priority 3. And we can conclude that this is the R structure. However, if the hydrogen is pointing towards you, it's not quite so straightforward. Now the hydrogen is pointing towards you, and the OH is pointing away from you. So you still want to assign the priorities as usual, but then you have two choices. One is to carefully flip over the whole molecule. You gotta flip the whole molecule, pick up your model, turn it around. You can't do any rotations or taking balls out and putting them back in another place. You have to flip the whole molecule over. Now the hydrogen's pointing away from you. You have priority 1, now 2, the ethyl group is on the left, 3, the methyl group is on the right. Okay, so this one now is going to be S. Or you could leave the molecule as drawn if you're not using a model as is, but reverse the definition. Okay, so you still have your oxygen with priority 1, your ethyl with priority 2, and your methyl at priority 3. If you just trace out your circle based on groups 1, 2, and 3 here on the screen, it's going to look like it should be R if that hydrogen were pointing away from you, but because the hydrogen is pointing towards you, it's actually S. So these are your 2 options. You can choose whichever one works the best for you, but you need to be consistent. You need to find something that works and stick with it. Finally, as you might have seen from what I was doing already, if you switch two groups at a stereocenter and leave the other two groups alone, that ends up inverting the configuration. In other words, turning R to S. So on the left side here, I have the R isomer of 2-butanol. On the right side of the screen, I have the S isomer. And the only difference in terms of the drawing is whether the OH is coming out and the hydrogen is going back, or whether the hydrogen is going out and the OH is going back. The equivalent with the models, then, is whether the ball is representing the OH is on the carbon closer to you, or whether the ball representing the OH is on the position on the carbon pointing away from you. Okay, so that tells you how you can get from one enantiomer to another by either drawing or making a model.